Question: what does a scientist mean when they use the word significant? Answer: probably not what you imagine. So what would most people imagine that a scientist would mean? Significant would normally be taken to mean impact. So some sort of real world impact is significant. So if a scientist is talking about a significant increase to your age, you imagine that they would be talking about years, 6 months, 8 months, 9 months. You wouldn't imagine that 5 minutes would be significant. Science involves comparing two situations. So with the age example, it might be that one situation is people who exercise regularly and the other situation is people who do not exercise regularly. And we would ask the question, is there a significant increase in age if you exercise regularly? But what would that actually look like? What would that significant difference look like? Well, the first thing is to decide how we're going to measure it. And normally it would be measured as an average. So the average age that people live to when they exercise regularly versus the average age that people live to when they don't exercise regularly. But it doesn't have to be an average. Now, that's not very well understood. We could look at the maximum age that people live to, for instance. Let's say that we've decided to measure the average age that people live to. The next thing we have to decide is what would a significant increase be. So this is what most people would understand by the word significant. And the scientist calls this the effect size. So what would be an interesting effect size? So 5 minutes would not be, 10 minutes would not be, half an hour would not be. If we collect enough data, we could actually tell a difference of half an hour, but realistically we wouldn't be able to. Would 1 month be significant? Well, certainly if you're on your deathbed, 1 month would be very significant. But let's say that it's a year. Let's say that we are interested in an increase of 1 year. So that's our effect size. So when the scientist says that there's a significant difference between these two situations, if they don't mean the effect size, what do they mean? Let's say our scientist goes out and measures the age that people live to when they exercise regularly, and they measure the age people live to when they don't exercise regularly. Now, for these two situations, there is an underlying process that determines the data that the scientist collects. So there is something that determines a person's age. And the scientist is wondering whether or not it's got something to do with exercise. If the two situations are generated or could be generated by the same underlying process, then this is not a significant difference. A significant difference means that the two situations have a different underlying process for generating the data. You might have heard of the null hypothesis. Scientists test the null hypothesis, and the null hypothesis says that there's no difference between the situation where people exercise regularly and the situation where people do not exercise regularly. Let's say that the scientist has done that and has found a difference in the average that people live when they exercise and when they don't exercise of 1 year. Now that is a significant effect size, but is it significant to the scientist? How would we measure this? Well, I've got on the board behind me a sketch of what the data might look like from one of the situations. So let's say that this is the situation where people exercise regularly. Usually it would look like this. It would look like a histogram, but I've drawn it as a pie chart to make a point. And the size of each slice is a frequency count of the number of people who have lived to be 70, 71, 72, 73, etc. And I will have the same thing for people who don't exercise regularly. To try and decide if the two pie charts could be generated by the same underlying process, what you do, or what you might do, is randomly select from one of the situations and insert it into the other situation, and then step back and see, can you tell what you've done? And what we're going to do is we're going to pick one of these pie slices at random. So if I look away and spin and choose randomly, we've chosen 75. If we do that, let's say 100 times, and calculate the average that we get, we can see, is the average that we get at least 1 year greater than the average we get here? And if it is, then it looks like there's no difference. Now let's go through that again. Now our two situations had a difference of 1 year. And what we've done is we have used one of these situations to ask ourselves the question, how likely is it that we could have observed this situation had the two situations come from the same underlying process? So we use this and assume that the underlying process is accurate, do this thing where we randomly select over and over again, and ask ourselves, is the random data that we selected giving us a difference of 1? And if it is giving us a difference of at least 1, then that is evidence that the observed data, where we observed a difference of 1, could have come randomly from the same underlying process as the first situation. And if the random data does give us a difference of 1, then it looks like the second situation is no different from the first situation. Now, what if the random data doesn't give us a difference of 1, if it gives us less than 1? Then that is evidence pointing in the direction that the two are different. Now, if we repeat this entire thing over and over and over and over again, we build up more and more evidence, and we can start to calculate a probability. So for instance, if we do this 100 times and 5 times it looks like there is no difference, then we would say that our p-value is 5%. And usually a p-value of 5% would be considered to be statistically significant. Now that is controversial, and usually what scientists do is report the actual p-value that they get rather than some sort of artificial idea of significance. But if the p-value is low, so if the probability of observing the difference that you do observe randomly through random chance, if that is low, then the scientist would say that they have found a significant difference. So there it is. The word significant does not mean big. What it technically means is there is a low probability of observing the results through random chance.